Hello everyone, welcome back. Today our topic is thermodynamics. If we focus on the topic itself, so therm and dynamics. So we know that thermal means heat, right? Heat, and dynamics means motion. So heat is one form of energy. So in short, the energy is having a motion. So when we will discuss on that topic, so it will be coming under thermodynamics. We should learn about thermodynamics. Of course, it is in our syllabus. That is the first reason, and the second, that is what is the need of this, right? So predicting the feasibility of a physical or chemical transformation. So we can predict. So predicting the feasibility of a physical or chemical transformation the first thing. And second is, of course, to generalize some physical chemistry problem, and which help to generalize some physical chemistry problem, and which helps to generalize what will be the experimental results. Okay, and also to somewhat predict the yield of a product. That is the need of studying or learning this chapter, thermodynamics. Now, before going through the equations or the generalization part, we should know some basic things. Okay, so thermodynamics, as we know that there will be energy change or exchange or transformation or energy in motion. So from which place to where it is going, right? So at first we will focus on system. System means it can be a test tube, it can be a conical flask, it can be, for example, we are test tube, conical flask, and also if we are doing a reaction in a beaker. So the investigating area will be our system. Okay, now then we will do the classification of different types of system. That means the portion we are working with, it is our system, it exists. And first one we will do as open system. Second one will be our closed system, and third one is our isolated system. Now I will explain it in terms of two things. One is the exchange of mass and one is the exchange of energy. Okay, we divide or we classify the system with respect to the exchange of mass and exchange of energy. In open system, mass and energy both can exchange between, one is system and one is surroundings. So what is surroundings? Except our system, the remaining part of the entire universe is our surroundings. Okay, the entire part of the universe is our surroundings. So mass and energy can be exchanged between the system and the surroundings, then that type of system is known as open system. Clear? Then closed system. So what will be the example of open system? For example, 1 cup of hot tea, okay, is example of open system. Why? Because as you know, this is exchanging the water vapor, that means mass, and of course it is getting the temperature is cooling down, so that means it is also changing the energy. So it is example of open system. Now for closed system, we are controlling one, that means we are taking the only exchange of energy, not the exchange of mass. Then it will be our closed system. Now how to represent? For example, that cup of tea, when it is covered, so as you know, the water vapor can't pass, right? So it is not exchanging any mass, but it is exchanging the energy. So it is one type of closed system. Now for isolated system, we are controlling both the exchange of mass and energy. That means their mass and energy can't be transferred between the system and the surroundings. Then it is known as isolated system. Now the thermoflask we are using in winter time, or in thermoflask we are using in summertime also, but the function is different. For example, winter time we are making tea and we are pouring the tea in a thermoflask to keep it hot to drink it later. The same thing we are doing, we are taking cold water. So this is example of isolated system. Now no system can be 100%, can't be 100% isolated. So example of this type of system, for example, we are not taking tea in any cup, so we are taking in a thermoflask. So then it will be isolated system. Clear? Now in order to understand more clearly, I will tell one another thing, that is the boundaries or walls. Okay, make a heading. So at first there are different types. First one, write down rigid. Rigid means it is somewhat real. For example, the wall of the cup, okay, it is one type of boundary or wall. For open system, we will use specific type of walls. At first let me explain one by one, then I will tell you which type of system we will use which type of walls. Okay, now rigid system, rigid wall. Then second one will be impermeable. Third one will be permeable. At first write down, then I am explaining. Then it will be diathermic or diathermal. And next it will be adiabatic. Okay, now rigid wall, that means you know that there will be a specific boundary line. Okay, specific boundary line, and we can't move. This is non-removable. Now for impermeable and permeable, we are classifying this with respect to the exchange of mass. exchange of mass. Impermeable membranes means impermeable walls means a wall which prevents the passage of matter is called impermeable wall. Passage of mass or matter. That means for impermeable membrane, the change of mass is equals to 0. Delta sign we will use for any change, for example before and after situation. Okay, so there will be no change of mass or matter, so delta, that is the change of m, will be 0. So and permeable membrane, the opposite one, which allows the exchange of mass or matter. Okay, now diathermic or diathermal, it is a wall which prevent the passage of matter, which prevent the passage of matter, but passage of matter or mass, it prevents, but it allow the passage of energy. Okay, in the absence of any external force, it allows energy to pass, and also in absence of any external force. In absence of any external force, that means in generally, if we are not adding any external force, of course external force we are allowing, that means something it is not happening and we are doing that thing, we are doing a change. Okay, but in diathermic world, it always allow to pass the energy, but it will prevent the passage of matter or mass. And when it is allowing the passing of energy, that means it is, the system is not in under any external force. Clear? And last one is our adiabatic. Adiabatic means it will prevent the passage of mass or matter, and also it will prevent the passage of energy. Okay, and also provided there will be no external force. So if we interlink these two topics, that means system and types of system and different types of boundaries or walls. So at first tell me, for open system, which type of walls should be there? One is rigid, of course, rigid is possible. And of course it will be permeable, right? It will be permeable. Why? Because permeable type of walls, they allow the exchange of mass or matter, right? But impermeable walls do not. So in closed system, as you can see, this cup of tea is having a proper rigid wall. So there we can also have rigid. But which type of wall or which type of boundaries we will use there? Of course it is impermeable. Clear? Now for isolated system, which type of walls we will use? At first write down in your copy, then I am telling. Yes, if anyone has written that the wall will be adiabatic, right? because as you can see, adiabatic, they don't allow the exchange of mass or energy, and here in isolated system we can't also um, consider the change of mass, exchange of mass or energy between the system and surroundings. So there we will use adiabatic type of wall. Is it clear, everyone?